you guys have both been talking about, motor control solutions here. Let's frame the question so that our users understand, especially those that don't have as much familiarity with motor control solutions. Ritesh, can you give us a background about motor control in general, maybe a high-level view of understanding of the challenges and some of the issues at a technical level that manufacturers face?
So it's a very big area. Motor control technology exists from ages, and father of legacy, Mr. Faraday, who spun the motor, and there was a lot of since then there was a lot of advancement happened in the technology side. But as Chris mentioned, that those technologies were very much in the hands of the PhD people or the people who are doing a lot of R&D work. What Renesas did, and actually very few people know that we have a very specialized R&D facility in Japan, and if you look at that, the majority of appliances in Japan, they have already adopted this advanced technology, whether we call it vector control or brushless DC control, long back. In fact, almost 90% of the appliances in Japan are using this technology. So when we were partnering with some of the technology company, also our in-house R&D facility, we found out that the biggest challenge is that how you can really run a control loop with very efficient manner, and also how we can make this much simpler to the people who have not done this motor control for long back or who have been just outsourcing. And in fact, it was so interesting to understand that many of the appliance manufacturers, until 5 years ago, they were just outsourcing the complete turnkey solution from somebody else in the world. They were not doing the motor. They were not doing the electronics around the motor. They were doing entire appliances, all the user interface, but not the motor. So the challenges were that how to really take that high-end technology into the market at a very low cost, and also how can you offer a complete solution, because these people were just learning the motor control, barely using the very simple algorithm, like, for example, 120-degree trapezoidal, and graduating from there to sinusoidal control or to go to vector control with very high-speed control loop. For them, it was a very big learning curve. So what Renesas did, we said, forget about just talking about microcontroller, because just microcontroller, processor, they do have a lot of resources, but can we provide a total solution to them, which includes, of course, your microcontroller, but around that, a lot of other components like your IGBTs or MOSFET, and then come to the whole world of software. That can they get some algorithm from us immediately so that they can run their motor? They should not spend a lot of time on the tuning the motors or calibrating motor. Can you provide a very simple graphical user interface where they can take our solution and really implement in their actual motor environment? So all those steps, we need to make it simpler. And those are the biggest challenge for appliance manufacturer to bring this motor control in-house. And I know and I appreciate that TI has done a very much similar work in the same field. Where we are focusing on now is to really make our customer give them an opportunity where they can simply go to our website, download all the software free of charge. We are not offering any money for any software. Also, we developed some of the kits which has all the software, the motor algorithms, everything, hardware, and everything inside. So the idea is to really remove this barrier of entry level, that how they can enter and start developing in-house. So that's the first point. The second point was that there's a big initiative has happened for the IEC and safety and compliance. So we started looking at people who have no idea in the beginning that, okay, this motor is a high voltage motor. This will come up with a lot of safety regulations. So we have helped them to really come up with this IEC safety algorithms, which have been certified. And also, like, for example, in the microcontroller, there's some of the routines, whether it's the watchdog routines, which is very important, to really make it IEC compliant so that people can get those things ready-made and not to really worry about too much later on. So technically what we're doing to reduce down the overall design cycle for these appliance manufacturers and make this motor control much more easier, and as opposed to it just a kind of PhD topic?
It's good for me to hear. I mean, Ritesh and I obviously are in the same markets, right? Everything he's saying, I can say, yep. We're visiting the same customers. We're understanding the same problems, right? I agree with him. There's that first level of, you got a great chip, you're going to put some software on it. You want to have that be modular that you can reuse. And I know Renesas is like us. They have a huge MCU portfolio, and a lot of their devices are quite different, right? Different cores, different peripherals. How do you make that as easy to kind of choose the right one? So I think we're on the same page there with where Renesas is going. The thing that we did is, honestly, about 2 years ago, we took a step back and said, we aren't solving that problem. We're putting piecemeal things out there, and only a certain segment of people can take what we're doing and make something great out of it. So what we did is we started looking at those things. How do you, stop spinning our motors in our lab. That's great. That's easy. Let's go say we're going to spin a customer's motor the day we move it first time. What's it going to take to do that? What's it going to take? It's going to take algorithms that either can identify everything they need, or they don't care a lot about what the motor is, and they're just going to go run, right? And then how do you let a customer do that? And then how do you take the next step of, okay, I can spin a motor. It's easy to do that open loop. I can spin anything open loop. But that's not what we're talking about here. We're talking about driving the type of efficiency and performance that we're getting in these high-end motor systems and taking that to the rest of the world. So how do I take that and really say, I'm going to spin your motor. I'm going to spin it the day I see you. It's going to be with an efficient, current-controlled algorithm, and it's going to be something that you can tune very easily. Right? And that's the steps we're taking. And we're putting the task to ourselves of, okay, here's where we are today. We can tune something very quickly as an expert in a matter of hours. We can now show a customer how to do it in a day, let's say, on a simple BLDC technique. Let's put the flag out there. We wanted to be able to do automated, field-oriented control, perfect current regulation, automatically tune speed loops, everything like that. Why can't we do it? And that's the challenge we've given to ourselves, and that's the challenge that we're solving.
So in terms of solutions, you both have already talked about the solutions you're providing. Maybe let's talk a little bit about the devices at the hardware level. So we've talked about software and IP that can go along with the devices. Have there been any changes made to the microcontrollers themselves to help improve and implement these solutions at a hardware level? Chris, maybe just elaborate a little bit in that area.
Yeah, sure. So specifically focusing on, the appliance space, which the appliance space at the high end I'll categorize as compressor systems driving for maximum efficiency, centralist washing machines which are highly dynamic. Those are the big control challenges in the appliance space. On the low end of that, you can think of, very simple blenders and things that are just kind of startup. And so those are all motor control applications in the appliance space, wide swath. And of course, it's going to take a different MCU, a different algorithm, and there's a lot of reasons you choose one thing over another. Right? At TI, we really have 4 microcontroller families that we present, and especially in this appliance space, really focused on 3 of those. So kind of going down the list, focusing on that high-end area first, down through the middle and the lower end. Our high-end family, the stuff that really gives you maximum performance is our Piccolo family, our 32-bit processor, DSC, real-time controller, DSP/MCU. All these terms have been used over the years. But it's our bread and butter machine that we've really driven not only the algorithm, but the interconnect that you need for real-time control when it comes to how peripherals and the CPU interact to do the best control in the fewest amount of cycles. And those devices are not expensive anymore. This isn't the day of a $15 DSP. These are online for under $2 to start, right? And we know the direction of that is only going down. So when it comes to performance for premium motor control, it's Piccolo. We also are seeing a big push in the world of ARM into this space, right? The ARM Cortex families are very popular. There's definitely a segment of the population who said, we love this concept of ARM. They're pushing, standardization. We like that. And we have a very nice offering from our Stellaris team. We're one of the first to come out with a Cortex M4F with real floating point working. We're actually releasing a kit at the end of this month, the end of August, which is going to be the first floating point kit that's doing sliding mode observer sensorless field oriented control. And this is a very good fit in that mid-range space where we can apply, very high-end techniques like field-oriented control, but also give the customer the ARM kind of environment ecosystem that we're looking for. And then we also have our MSP430 family. This is our 16-bit processor lineup. Typically, this is kind of our low-power, going after not necessarily motor control applications, might be used in simple kind of supervisory functions, general purpose control, but it's obviously can do things that are controlling brush motors. And we've actually been applying it to do, again, insta-spin BLDC, our sensorless BLDC technique, which will spin your motor instantly. And we actually are running our sliding mode observer techniques on it as well. So we're applying this in lower dynamic applications like fans and vacuum cleaners and small pumps. So for my team, we don't care about the processor. We do everything from the solution level. And we actually have set up our own internal infrastructure that we're now releasing out to customers. Our infrastructure is built. It is agnostic to the processor, right? We write special drivers, but then we use those drivers at an agnostic level. Our same system code is running on MSP430, is running on Polaris, is running on Piccolo, and is also running on our Hercules ARM Cortex-M4 safety processor, which is slightly different.
Ritesh, tell me a bit about Renesas' offerings.
I think in the last 10, 15 minutes, this is the first time we had a little bit of disagreement with Chris, and I would provide my perspective. Just one point that Chris mentioned about he has, or TI has, different level of families with Piccolo and ARM, and the MSP430. That's pretty good. And in fact, where we are heading, that we want to offer people a seamless migration and one architecture where they can go up and down. We did have very similar way in past where we had high-end SH class of processors running around 1200 DMIS performance for high-end motor control, and then mid-range we had RX or low end with RAC. Now what we're trying to do is that with any appliance manufacturer, when they develop the solution, they're not only developing for high-end compressor, they're also developing this blender. And they would like to protect the code base. So we have expanded the RX family pretty dramatically up and down. So now within the RX, you can get a $1 microcontroller as well as you can get a $2 microcontroller or even higher if you need higher DMIS performance. So that's the one point of what we have did a little bit differently in the marketplace. The second thing is that Chris mentioned about the ARM popularity, and you mentioned about that people feel that it's very easy to migrate from one ARM to other ARM. I strongly disagree with this point because it's not the architecture who does matter. It is mainly the peripheral who does matter. And it is almost impossible to move from TI ARM to somebody else ARM. And I think Chris would not like to see that somebody moving very easily from TI ARM family to Freescale ARM or somebody else, basically. So the point is that over here is motor control, that people do care about the integration, that is very geared towards motor control. So days are gone when people were offering a general purpose microcontroller and say, hey, here's the motor control micro, use it. What we did, we said, no, within our RX portfolio, we have an entire general purpose lineup, but then we have a motor control lineup, which is called 622T or 63T, and so on and so forth. Whether we have a T in the end, that's our motor control family lineup. And RX 62T has been designed specifically for motor control and especially to address some of the very critical elements. For example, 5-volt operation. The entire industry is now moving toward 3-volt, or all semiconductor people basically, because it's cheaper implementation. But Renesas is the only left where we still want to keep a 5-volt operation of the microcontroller because motor control requires that helps to have more dynamic range of A to D, better control loop, and of course it is much cheaper on the noise immunities perspective. We have also added a lot of peripheral like FPU, as Chris mentioned, that I think they are looking at to introduce that family shortly. The RX, in general, all the devices in the RX, majority of devices in the RX, they do have FPU built in. So FPU is the default feature for us as far as motor control is concerned, or even for general purpose marketplace. So we have brought that technology from DSP world to the microcontroller world and make it just a free of charge, no extra cost for having an FP on board. The other feature that we have added very specifically for motor control is 3 sample hold on A to D. Generally, people put a 1 sample and hold with a 2 unit or 1 unit of A to Ds, or 2 sample and hold for two shunt detection technology. But we do offer 3 sample and hold circuitry on our 2 unit of A to Ds, which is offered much more flexibility, much more dynamic range for implementing even 3 shunt vector control algorithm. Similarly, we have added the 6 PGAs and comparators, which are also very, very important when people are looking at this dynamic control and running at higher carrier loop or higher frequency. So these are the elements that we wanted to really explain to the audience, that it's not only just a simple control microcontroller or microprocessor. It is all what is coming in and built into that, which is geared towards the motor control. And we don't want to say that here is a general purpose microcontroller with a motor timer and use it, but look at inside and what is there that can help you out design your system much more efficiently.